Welcome to the cutting edge of modern medicine. We are standing at a crossroads where hope meets hesitation and scientific breakthrough clashes with deep moral questions. This is the world of stem cell research. Today, we are diving deep into a topic that promises medical cures, but also sparks intense ethical debate. We will explore the potential to heal the unhealable and the controversy that has defined this field for decades. To understand the debate, we must first answer a simple question. What is a stem cell? Think of them as the body's master cells. Unlike the other cells in your body that have a fixed role, stem cells are unspecialized raw materials. They possess a unique blank slate ability, meaning they haven't decided what they want to be yet. This gives them remarkable flexibility. Depending on what the body needs, they can transform into muscle, brain, blood, or even bone cells. Let's put this into perspective. Most cells in your body have gone through a process called specialization. They have a fixed career path. Once a cell becomes a heart cell, it stays a heart cell. It cannot change roles once assigned. Stem cells are different. They have a distinct advantage. They are the only cells that can choose their career path before becoming differentiated. This ability to pivot is what makes them so valuable to science. Not all stem cells are created equal. Broadly speaking, there are two main types. First, we have embryonic stem cells. These are found in early-stage embryos and possess practically unlimited potential to become anything. On the other hand, we have adult somatic stem cells. These are found in developed tissues like bone marrow and fat, but they exist in much smaller numbers. Let's look closer at the first type, embryonic stem cells. These are found specifically in blastocysts, which are embryos that are only 3 to 5 days old. At this incredibly early stage of development, these cells have a pluripotent superpower. This means they can become any cell type in the human body. This uninhibited versatility offers the highest potential for curing diseases because there is no limit to what they can repair. Now, contrast that with adult stem cells. These are found throughout your life. Whether you are a child or an adult, you have them hiding within various tissues. However, they come with a limitation. They are multipotent. This means they can only become a few specific cell types, not unlimited possibilities. A blood stem cell can make new blood, but it can't easily build a new brain. So, why are scientists so desperate to study these cells? There are three main reasons. First, they allow us to study disease development. By watching diseases grow in laboratory dishes, researchers can understand the mechanisms of how illness starts. Second, they provide a path for safe drug testing. We can test new medicines on cultured cells rather than risking human subjects. And finally, the Holy Grail, regenerative medicine. The goal is to replace diseased cells with healthy ones for breakthrough treatments. Imagine the real-world impact of this. Consider diabetes. In type 1 diabetes, the problem is that the pancreas stops producing the insulin hormone. The stem cell solution is to grow entirely new insulin-producing cells in the laboratory. If successful, the result would be life-changing. It would mean no more daily insulin injections required for millions of people. Or consider spinal cord injuries. Currently, this is a permanent condition because damaged spinal cord nerves do not naturally grow back. Once that connection is broken, it is usually broken forever. But stem cells could bridge that gap. Clinical trials are already underway to use these cells to help paralyzed patients walk again. We are talking about regenerating the very wiring of the human body. But this potential comes at a heavy price. This brings us to the controversy. The central issue is an ethical dilemma. Obtaining embryonic stem cells usually destroys the embryo. This raises difficult, profound questions. The debate hinges on one concept. When does life begin? Is a 5-day-old cluster of cells a human life, or is it just biological material? This remains a deeply divisive debate. It is important to understand where these embryos actually come from. They are not created solely for research. They come from IVF clinics. Couples undergoing fertility treatment often create many embryos to ensure success. This leads to leftover embryos. After a successful pregnancy, these unused embryos are either frozen or simply discarded. The option for scientific donation allows parents to donate these leftovers to research instead of letting them be disposed of as waste. Those who argue for this research emphasize the moral duty to cure. They argue that an early-stage embryo lacks a brain and a heartbeat. It is not yet a person in the functional sense. Therefore, they believe it is better to use these leftovers for cures that can save existing lives, rather than simply disposing of them as waste. On the other side, the arguments against research are equally passionate. The core belief here is that the embryo represents potential human life, regardless of its development stage. To destroy it is to destroy a life. Critics argue that research should focus only on adult stem cells, which avoids these ethical concerns entirely. For years, this debate seemed deadlocked, but then science provided a new path. The solution might be iPS cells, standing for induced pluripotent stem cells. This was a revolutionary discovery in 2006. It found a way to transform regular skin cells back into embryonic-like cells. The beauty of this is that no embryos are destroyed. It acts like an embryonic cell, but is created ethically from adult tissue. How does iPS work? It's almost like magic. Scientists add 4 specific genes into a regular skin cell. These genes act as a reset button. The cell effectively forgets its identity as a skin cell and returns to a blank slate state. This discovery was so monumental that Shinya Yamanaka was awarded the Nobel Prize for it. While iPS cells are the future, we already have decades of success with older methods. Look at bone marrow transplants. This is a proven stem cell therapy used for treating leukemia and blood cancer. The treatment process is intense. Chemotherapy kills the cancer, and then healthy blood stem cells are injected. The result? The patient grows an entirely new immune system. It is living proof of stem cell power. However, where there is hope, there is also exploitation. We must warn you about stem cell tourism. There are foreign clinics that promise cures for everything from blindness to autism and aging. These are often unproven miracle claims. Be very careful. These unregulated treatments can cause tumors or even death. You should trust only approved trials. We also need to clear up a common misconception about cloning. There are 2 types. Therapeutic cloning involves cloning cells to repair damaged organs, which is legal in some regions. But reproductive cloning, the idea of cloning whole human beings, is illegal everywhere. That is not what stem cell research is about. So what does the future hold? Imagine 3D printing organs. Scientists are working on using stem cells as biological ink to print replacement hearts and kidneys. We are also moving toward personalized medicine. In the future, doctors could test drugs on your own stem cells to find the most effective treatment for you before you ever take a pill. To summarize, stem cells are truly the body's repair kit, holding the key to curing currently incurable diseases. While the ethical debate over embryos has been fierce, the rise of iPS cells might solve the controversy while maintaining the powerful potential of this science. We are witnessing the dawn of a new era in medicine, one where the body's own cells become the cure.